Hello, everyone, and welcome back. Today, we are going to be doing our sine and cosine law word problem. So, just a reminder, we've already done the sessions about sine law and cosine law and what those are. So, if you haven't watched those, make sure that you do, because those are going to explain how to use sine law and cosine law, and also when to use sine law and cosine law. But what I will review actually is when we'll use each one. I will review that here today. I think that's fair. So before we even get into any questions, when will we use sine law versus cosine law? So pretty much whenever we don't have a right angled triangle, we know that we're going to need to use either sine law or cosine law because the basic trigonometric ratios that we learned in grade 9 or grade 10, those are not going to work for triangles that aren't right triangles. Okay, so right away there, if it's a right triangle, we can use those basic trig ratios. If it's not, then we must use sine law or cosine law. Now, sine law is nice and quick and short and easy. All we have to do is plug some numbers in, cross multiply, and bam, we're done. Cosine law, on the other hand, is longer and more complicated, and it's a variation on Pythagoras' theorem, but with some more steps, right, to account for the fact that Pythagoras' theorem also is a theorem that only works for right angle triangles, whereas cosine law works for all triangles. So we had to add that in. Um, and so, for that reason, it's always best to use sine law whenever we can and only use cosine law when we have to. So, if we only have sides and we don't have any angles, then we must use cosine law because sine law requires us to have, at least one side angle pairing. And if we have no angles, then we do not have at least one side angle pairing. The other time is if we have side angle side, right? So we have an angle, and then we have the two sides that are adjacent to that angle, but we don't have the opposite side, right? That's the other situation where we would use cosine law because we don't have a side angle pairing, right? We have one angle, but we don't have the opposite side of it, and then we have two sides, but we don't have those other two angles that we would need. Now, that said, of course, you can use cosine law for anything you want to, and it will not give you the wrong answer. It's just that those are the only two scenarios where we must use cosine law and we aren't able to use sine law or any other methods that we know so far. And so, therefore, it only really makes sense to use it in those cases because sine law is just a lot faster. So no worries if you do use cosine law and you didn't actually have to. You'll get the right answer. It's just that it'll take you longer than it really needed to. So let's get into example one. It says, on a 520-meter hole, a golfer's tee shot goes 175 meters and is 20 degrees to the right of the direct path to the flag. The second shot goes directly into the hole. How far did the golfer hit the second shot? Okay, so basically we have a 520-meter hole. The golfer's tee goes 175 meters and it's 20 degrees to the direct path of this flag. So in golf, right, we're trying to hit a little ball into a golf hole. So let's say that this is our little flag. We're trying to hit it into the hole with the flag, right? And so this is the direct path. The direct path is 520 meters, it says. And it says that we're shooting it to the right of the path, which actually would be the other side, but I'll just draw it to the left of the path. It doesn't actually make a difference to us. 20 degrees right here. And the second shot goes directly into the hole. So we have our 20 degrees, and then we have our second shot, and the second shot does go directly into the hole. And this shot here, the first shot, goes 175 meters this way, actually. So I guess that's a bit less. I'm going to try and draw that a little bit more accurately, that it wouldn't be quite as much. And then there we go, because I do expect to get a larger number for that other side. And then it says, how far did the golfer hit the second shot? So in other words, what is this, right? How far would we have to hit it the second time? Okay, so let's go for it. So what do we know here? Well, we know we have a side angle side situation, unfortunately, which means we have to use cosine law because we don't have a side angle pairing. The only angle we know is the 20 degrees, and the side across from it we don't have, and therefore it's one of those scenarios where we do need to use cosine law. So let's use cosine law. We're trying to find the side x squared. So using cosine law, x squared is equal to 175 squared plus 520 squared minus 2 175 520 times cosine of 20 degrees. So now we're going to grab a calculator and we're going to calculate that and figure out what is x. Okay, so let's first find out cosine of 20, and make sure in this case that you're on degree mode, that you see a little DEG at the top, very important. All right, times 2 times 175 times 520 is going to equal to that, okay, plus 175 squared plus 520 squared, okay. All right, so we're going to have 171,024.057 over here. Then here we're going to have 175 squared, which is 30,625. Then we're going to have 520 squared, which is going to be even larger. Looks like 270,400. All right, plus 30,625 minus 171,024.57. All right, so in the end, we get that x squared is equal to 130,000.43, which I'll just forget about the 43. I'm more worried about the 130,000. And let's take the square root, and we get 360. So before I just move on, I'm going to check that that answer makes sense. So we know that it's going to be between 175 and 520, which it is. And we also know that 175 plus our answer must be greater than 520, which it is. It's going to be 535 if we add 360 and 175 together. If we get less, we wouldn't really be able to make a triangle. So that reinforces the fact that this is the correct answer, 360. Now, because this is a word problem, I'm also going to write a conclusion statement. Some teachers require this, others do not, but I'm going to write one in case it is something important for your teacher. I'm going to say, therefore, the golfer hit the second shot (360 meters), or you could say approximately 360 meters. We did do an approximation there, that's for sure. All right, let's move on to example 2. Example 2 says, a lighthouse is able to shine its light so that two boats, A and B, are just visible. Boat A and B are 7 kilometers apart, and the lighthouse is 5.7 kilometers from boat A and 6 kilometers from boat B. What is the angle of the spread of light coming from the lighthouse? Okay, so I'm going to draw a picture. So here's my lighthouse. That looks a little more like the CN Tower, but anyway, that's my lighthouse. And it says here that we have boats A and B that are 7 kilometers apart. So let's draw boat A is here, and boat B is here, and this is 7 kilometers apart. And then it says that boat A and B are 7 kilometers apart. We read that part, and the lighthouse is 5.7 kilometers from boat A. Okay. And then 6 kilometers from boat B. What is the angle of the spread of light coming from the lighthouse? So basically, they would like to know, what is this angle here? I'm just going to call it x degrees. Now, in this situation, they literally, if we look back in the question, they did not give us any angles whatsoever, and we don't even know that this is a right angle triangle. In fact, we know it's not a right angle triangle based on what the question told us, and just the fact that has to do with sine law and cosine law and not anything else. And so for that reason, we know that we are going to have to use cosine law because we were not given any angles, unfortunately. So let's do that. There's a variation here. So this was the one version of the cosine law. There's a second version I'll remind you of, which is this one right here. It's the same thing. It's just this formula changed around a little bit so that we have cosine of our angle to go off of. So cosine of our angle, cosine of angle x is going to be equal to b squared plus c squared minus a squared over 2bc, right? So it's the same equation as before, but we're just, swapping it around a little bit just to make it easier for ourselves. You can plug everything into the original equation. Absolutely, you can. However, if you do that, there'll just be a few more steps for you with the rearranging part. Okay, so let's do it. So we have cosine of angle x, which we don't know what angle x is, so nothing to plug in there. Then we have the angle opposite to angle x, which is 7 kilometers. That's going to be A. It's very, very key here. Make sure that your angle opposite to that your side opposite to the angle you're looking for in cosine law is always, always, always A. B and C, it doesn't matter, they're interchangeable, but A has to be A, so we must put 7 here and not in either of the other ones, or we won't get the right answer. That's how important it is. All right, times 2bc. And then I'm going to punch that in my calculator, and we're going to find out what that is. So we have 5.7 squared plus 6 squared minus 7 squared. And then we're going to divide that by 2, and 5.7 and 6. And I'm going to get about 0.285 approximately. And then what I'm going to do is I'm going to press the second function button and then cosine to get inverse of cos, and then press enter, and that will give me x. X is equal to 73.44. Now, in general, they usually do ask you to round to the nearest number of degrees. Here, they didn't actually specify that, but I'm going to assume that here as well, that it's approximately 73 degrees. So let's put that in. The angle of the spread of light is about 73 degrees, and that's perfectly good, right? And if we think about it, for an equilateral triangle, because these sides are all relatively equal, right? For an equilateral triangle, it's always going to be 60 degrees. So we knew that it was going to be relatively close to 60, but a little more than 60, right? Because the longest side is opposite to this. So something a bit more than 60, but nothing too far from 60, right? Certainly not an obtuse angle or anything like that for this one. So that's good. That makes good sense with what we would have expected. All right, let's move on to number 3, and then that will be it for today. All right, this one says, when laying an underground cable, a workwoman uses 250 meters long straight property line as a reference. The angle from one end of the property line to the house is 64 degrees, and the angle from the other end of the property line to the house is 71 degrees. What is the shortest possible cable length that can be used to get from the house to anywhere on the property line? Okay, so first of all, let's draw a picture for this. So first sentence says, when laying an underground cable, a workwoman uses the 250-meter long straight property line as a reference. So basically we have a 250-meter line, long story short. It's okay if we don't know too much about underground cables and what the workers do. The important thing here is that we have a line that is straight and that is 250 meters long. That's the important thing. The angle from one end of the property line to the house is 64 degrees, and the angle from the other end of the property line to the house is 71 degrees. So basically this property line is underground from a house. So let's say this is above ground, and here we have this is not the best drawing, but we have a house basically. So one of them is 64 degrees, and the other one is 71 degrees. No, that's not really right. You know what? Let's try to make this a little more to scale and say this one is going to be the 64-degree one, and then this one, or sorry, this one would be the 71 degrees, and this one 64 degrees, because this one is a bit smaller, so let's try to make it somewhat good. And then it says, what is the shortest possible cable length that can be used to get from the house to anywhere on the property line? So first of all, we need to know, well, which one of these is shorter, right? Because it's going to be one of these that's going to go to either end of the property line, right? Now, which one specifically would it be, though? It would be the longer one that we would need, because it has to get to everywhere on the property line, right? The one on this side here, this wouldn't be able to reach to everywhere. It could reach to all here, 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 here. It would stop at some point, right? This one, it couldn't go all the way here. It's not going to work like that, unfortunately. Whereas this one here, that's on the longer side, this can go, this could go here, this could go here, this could go here, this could go anywhere on the property line in that shortest distance. So keep in mind, that's why we need to find this one here as opposed to the other one. And that's also partly why I wanted to, make them a little bit more accurate, right? So it's this one we're going to be finding. Okay, so next what we're going to do is we are going to decide, are we going to use sine law or cosine law? Now this time, I think that we ought to use sine law. And here's why. Even though we don't have all three angles, we can easily find this angle, right? We can easily say that 180 degrees minus 64 minus 71 must give us this angle. Now, why is that? Because all three angles in a triangle must add up to 180. So by subtracting off the other two sides, we're able to easily find out that this is 45 degrees. Now, I know it doesn't look like 45 degrees, but doesn't matter. It is still 45 degrees for our purposes today. The drawing is not really that to scale, unfortunately, so my apologies for that, but no, the drawing is not really that much to scale, I'll be honest. Anyway, though, let's figure it out. Let's figure out what x is. So we know that sine 45 over 250 is equal to sine 71 over x. Now I'm going to swap things around and say x is equal to 250 sine 71 over sine 45. And let's figure out what that is. So 250 sine 71 divide by sine 45. That is going to be 334 approximately. Now, I know my drawing isn't to scale. It doesn't look like it would be like that. But if my drawing was more to scale, right, 71 degrees and 64 degrees are certainly much bigger than, a small 45-degree angle. And so, if I do this more to scale, it would look more like that, even though the way I drew it, the 250 meters does look like the longest side when actually it shouldn't really be. So this answer is indeed the correct answer there. So therefore, the shortest length that can be used is 334 meters. All right, well, that is everything for today. Congratulations, you finished the trigonometry section of this final unit. Next time, we will talk about periodic and sinusoidal functions, and that is going to be the very last kind of topic of the entire course. So congratulations for making it this far, and we'll see you next time. Bye.